Just trying to access the demo device that we have here. I'll be back in a few minutes. Okay, thank you for waiting. So supervisor polling are the parameters that you can see here under real time. Okay. So these parameters are read-only parameters, meaning the XWEB is only pulling the data from the device. So samples of this would be probe readings, statuses, and alarm outputs, as well as the status of switches or digital inputs. Okay, the parameters are the read and writable parameters. So samples would be the set points, which you can configure from the XWEB and send the data or the changes to the third-party device. So that's the definition of the parameter or the read and write Modbus registers. Okay. Okay. Next step would be the editing the device property. So clicking here on this icon, the hand icon or the pointer icon, would show you this screen. So this would allow you to put in the family, the release number, and the EEPROM number. Dixell devices would have specific family codes, release, and EEPROM numbers. But for other third-party devices, I don't think they have these codes. So you might have to create a unique number in order to avoid confusion in the future, just in case the manufacturer decides to release a different version of the same device. Okay, so these are unique identifiers. Next would be the communications tab here. I'm not sure if you can see it. I can show you the tab here. So this is the communications tab. So this is the default. These are the default settings. So these are the meanings of these numbers here. So first digits would be the baud rate. Default is 9600, but for example, what if your device is set at 19,200? All you have to do is edit that. By the way, these are only for the default values. Upon commissioning, you would still have to select which baud rate are you going to use. But this is just these values are just for the defaults. Okay. So N means no parity. So the other options would be E for even and O for odd parity. 8 is for data bits, and 1 is for stop bits. I think these values are universal for Modbus devices. 8 data bits and 1 stop bit. So these are very common. Most variations would be on the first two, baud rate and the parity. And these other parameters are the defaults, the timeout and the timeout reset times. You can leave them as is unless specified by the third-party device. So these values would be okay, but it would be best to refer to the third-party devices manual. Okay. Next tab would be a supervisor. So under supervisor, you would have these. These are the four important digits. So 1, 3, 5, 16. These are the Modbus function codes used by the third-party device. Let me just pull up the. For example, the first digit is what how you would read a digital value. So the default is 1, meaning it would read coil statuses. So if most of the registers or all of the registers used by the device are coils, so you might want to use this, or you have to use this. If most of the registers that you have to read are input statuses or input registers, you might have to change the command to 2. That's for the read digital command. Next digit is the read analog command. So 3, that would correspond to function code number 3, meaning read holding register. So if the analog values on your devices are set as holding registers, you have to use 3. Uh, Dixell devices would only have 2 kinds of registers. They're either coils or holding registers most of the time. But third-party devices would use input statuses and uh, input or internal registers. The next lines would be the writing values or writing commands. So it would only write, for example, number 5 is a 4 single coil or write single coil. So that means it would be forced. It would only force all of the coil values. So it would not force other registers for the digital. For analog value 16, it would preset or write multiple registers. So these are very common parameters for or Modbus commands used uh, by Dixell, but some third-party devices might use input registers or input statuses. So the first 2 digits might change. Normally, the third and fourth values are universal because only coils can be only digital coils can be written or can be configured, as well as holding registers, analog holding registers. Okay. Next would be the language, but it doesn't have actually any bearing at the actual language of the file. It's just a label as to what language is being supported, because in reality you have to type in the name of the parameters one by one. So it doesn't have a built-in translator. Okay. Any questions so far? Okay, so I will proceed to the next part. Yeah. Okay, next step, we have to create a data type group. So you have to click on the math icon to show you additional properties. Upon clicking, you would notice that it would show another set of parameters at the right side. So in this example, uh, we will click on the types category, and then under data, you have to right click and select add math node. Then it would show another set under data. Just double click on that, and then you can change the data type of the register. What does it mean? It means that you have to set up the data type if it's a signed value or unsigned, the gain and the offset, as well as the number of decimal places. NDEC means number of decimal places. So here are the default values upon startup. You would notice that you have five. So all you have to do is click one by one. So you would notice this one is assigned value. You can change that to unsigned if needed. Then the gain or uh, mm, the mul- the multiplication factor. Then there's an offset if you need to add or subtract a value. Then there's also the number of decimals. So this is where you set these parameters. Okay. So you have a few pre-configured options, but for example, you might need an option that is not included here. So yeah, all you have to do is select data, then add math node. Uh, You might want to create your own custom-made data type. Okay. For example, you made a mistake, or you may want to delete the data type that you created. All you have to do is highlight the data type and then click on the X icon. Uh, some integrators might get confused with these, with the X icon. They thought that it would close the selection. But in order to close this selection, you have to click on the math icon and not here, because this will delete the data type. Okay, then the next data type that we'll tackle will be the list. The list is usually used for valve types or refrigerants. In this case, just click on math, expand lists. If there normally there are no pre-configured uh, options, so you have to create one just by right-clicking on lists, then add math node. Double click on that list, and then now you can create your own list. So in this sample, when the device sends a value of 0, that means it's an R22. So let's just copy the list provided here. Okay, so what does this mean? So if the register sends a value of 0, the XWEB should read a value of R22 or display a value of R22. Then what if the user wants to change it to R44? That means the XWEB should send a value of 2. So this is the index and this is the data that it represents. Okay. Okay. I think at this point we can now start with the creation of uh, read read only registers or supervisor polling. Okay. First, make sure that at the bottom of your Lib-builder tool that you've highlighted the supervisor polling option. Okay. Then from here, all you have to do is click on this icon to add a row. Okay, so these are just the default values. You can simply hit OK on these since we are going to edit these one by one. So just hit OK. Then let's copy the registers in the example. Okay, the name of the register is temp. You can call this temp. The first the first column is just named label. So this is not the actual name that would be displayed on your XWEB. It would be the description. So under description, let's call this temperature. Then for the group, there you have a pre-programmed option. So you cannot add anything under the group. So you have to select which one would you want to use for this particular set parameter. So in this case, this is analog input because this is temperature value coming from a probe. So let's call this let's put it under analog input. Okay, the next would be the dimensions. This is where you set up the Modbus address as well as the bits that are being used by this register. So in this case, the word address is labeled as 0100 and the label is hex. So you have to set it up as a hex input. Just type in 0100. Please be careful with this one because other devices might use decimal instead of hex. So just make sure that you look very carefully on your Modbus register list. Okay, so next thing that we would be looking for here would be the number of bits being used. It says here that's supposed to be 16-bit signed value. Okay, so if it's a 16-bit signed value, the length should be set to 16 or 0010. That should be okay. When you hit OK, it would look like this. You would notice that the hex value of 100 has been changed to 256. This is the conversion. This is the converted value to decimal. So in 10100 in hex is equal to 256 in the decimal system. After doing that, you can go ahead with the type. You would notice it's highlighted in orange. So just click this icon. Now you would notice that it would allow you to go into the math uh, data types that we've created earlier. So in this case, it says here that your value is supposed to be. Let's just go back a bit. Okay, so the value should be 16-bit sign, 0 offset, and there's a 0.1 gain. So if we take a look at our value here, so we're looking for a 0.1 gain and an offset of 0, and it should also be assigned value. So we have two here that might fit our requirement. The only difference between the two is the number of decimal places. So it would be up to you to decide which one would you want to use. Uh, some devices might give you a decimal place, so other devices might not. In this case, uh, the suggested value is 1 for the decimal place, so you might select that. But for example, other devices might, or other customers might want to see a more precise value, so they might require added decimal places. In those cases, you'd have to create another data type using the procedure we've encountered earlier. So in this case, let's select this one because it fits our requirement. So just hit OK. Okay, unit. You may type in degrees Celsius, C. Then you might want to leave the minimum and maximum values as is, or since these are 0 to 100, you may want to leave these as blanks. But in actuality, these two would not matter since this is an analog input. So the XWEB would only display what is being read from the device. So you may leave these as is. Next would be the data type. Data type is, since this is a 16-bit signed according to the document, then we have to select 16-bit signed. Okay, and that's how you create an analog input. Do you have a question, by the way?
Fernando,
Yes.
is this some sort of programming?
A little bit. The Lib-builder is used to create libraries for the XWEB that enables the
Though,
XWEB to display values from third-party devices. So yeah,
okay,
just a little bit.
but is a program include the parameter, right?
Uh, the program includes the parameter.
Yeah, because I see when you're doing the setting just now,
Mm-hmm.
it's some sure you are programming for the third party parameter. Is it correct?
This is just for the analog input. So this is how the XWEB would read the register.
Okay, understood.
Okay. Okay. Let's proceed. So Next would be a digital input. So let's read the register here. In order to add another level or another row, you might click here, or you might simply insert another row. Okay, then all you have to do is proceed with the next uh, register. In this case, it's a generic DI I1. Not sure what that is, so I'll just type the label as DI I1. Take note that I did not put any spaces under the label. Please make sure that you don't have any spaces on the label, or it might cause an error in the XWEB. You might put the spaces here under description. Okay, so this should be a digital input. So just select digital input under the group. Then under dimension, you would notice that uh, it always goes back to 1. So we have to type in the value here. So it's a hex input. Read register is 8051. So just type it in 8051. Okay. And for the coil, this is a coil type of register. You would notice that it has a mask and a value. So we will put that in uh, under the byte type. But first, you would notice that if it's a digital input, the type is no longer required because it says here type is derived by group. So if it's a digital input or a digital output, it will not be required because the only values that would come out of a digital register would be either on or off. So there's no need to put anything. Okay, next would be the mask and value. What does it mean? What does this mean? Mask and value are the specific bits that are being read uh, for this register. So let me just pull out my programmer calculator here. So the bits are in binary. So in this case, they say it's bit 20 or mask 20, value 20. It only means that they're reading bit 20 and expects the value 20. How does that work? For a hex value, I'm just using a programmer calculator application on my computer. Okay. So I just type in 20 and it converts the number into a binary value. If I click this option, the bit toggling keypad, you would notice that one of the digits changed from 0 to 1. For example, I delete this value, it goes to 0. I type in 20, goes to 1. So this is a digital value. So for digital values, it's expressed in bits. An on signal would be 1, and an off signal would be 0. So what this means is that it's looking for this specific bit to turn on for it to show a value, an on value. So It's reading 16 bits in total based on our dimension here. It's reading 16 bits in total length, but it's only looking for one particular bit. So how do we program that? We go to the byte type. That's where we type in the mask. And the VMAT is the value. Let's hit that one. So this tells the XWEB that you only have to read bit number 20. Then for digital values, normally it is set as a 1-bit Boolean value. Since you only need a 0 and a 1 to deliver a value. Okay. Any question on the digital input? Okay, and if there's none, we will proceed with the device status. So a device status is also a digital input because it only shows you if a certain a mode is on. For example, for keyboard, if it's locked or not, if the device is on or off, or maybe the compressor is on or off. So this is what is meant by device status. So let's just create one. This one is labeled the keyboard, so I'll just name it keyboard. So select the group status. Then the same thing for the uh, address is in hex, right? In the hex value. Okay, this is a digital value, so the type is not needed. Okay, you would notice it also has the mask and value. So same thing. Just type it in. And since this is a digital value, it uses a 1-bit Boolean value as well. But in the XWEB Lib-builder, you can also use the copy and paste function. So just hit Control C on the value to be copied, then hit Control V on the cell where you want to transfer it to. Okay, so it's basically the same as the digital input setup. Only difference would be the group. On an actual XWEB, this would be the group here. So it's more of like a way to organize all the registers. Okay. Feel free to ask questions. Okay, next would be the alarms. So alarms are also considered as digital values because it's either your system is in alarm or it's not. So alarm values are either on or off. Okay, so let's create this one. It says here error PB1. Okay, normally it means probe one failure. Let's change the status to an alarm. Okay, then follows the same structure. Since it's a digital value, just type in. Please take note that not all digital values might have a maximum value. If it's not shown on your Modbus document, you might ignore these. So you might leave it as blank. Okay? It's the same 1-bit Boolean value. So that's how you set up an alarm uh, output. Okay. Okay. Commands. Commands are also under the or are programmed under the supervisor polling part of the screen. So let's go to the supervisor polling tab, and then let's create this command: a keyboard unlock. Unlock. So this command should force this would force the register to unlock the keyboard. So how does it look like on the XWEB Pro? So it would look like this. It would look like a button. If you click one, it would force the value to turn on. For example, this one. So this is how the commands would look like. So how to program one? So the Dixell devices would have a different format on how they present the commands. There you go. Let's proceed. Some devices would have simpler formats. Unfortunately, Dixell devices have a different format. So, uh, under the dimensions, the first 4 digit is normally reserved for the address. So that then under the type, you have two options for command. Either it's a bit or a register, meaning it's either a coil or a holding register. So in this case, we are not really sure. So at the moment, let's set it up as a register. So in order to be sure as to what type of command register is this, you'd have to refer to the actual document. So this is a sample document. So you would see that there's a writing function. So the writing function, let's say, is a 0.5. And a 0.5 writing function is a single coil. So let's set it up as a coil or a bit. Then the last four digits would normally be the bit number. So in hex, bit number 008. Let me just convert that to decimal. The value is 8 as well. So this is what this means. So if you want to unlock input, the XWEB should send a value of 8 to the specific bit of address 500 for it to connect. This is the Boolean command or digital command. Let's select one bit Boolean. But this might change depending on the actual register. Okay. So far, any questions? Okay. If none, I'll proceed. Next, next would be the set points. Okay, so let's add a set point here. Let's just add another row. Let's type in set point. It should be under the set point tab. Okay, read register is 3044, also a hex value. Okay. Then the unit, Celsius. You would notice the gain and the decimal places. Then the offset are the same with the temperature reading. So you might just copy the data from the temperature input. So just Control and C, then Control V and paste. That makes it faster. Then you would notice that this is a read and write parameter. So you might have to put in a minimum and maximum value here. So it would depend on the actual document that you have. In this case, let's put in a -50 to 150. Okay. And it says here the format should be 16-bit signed. So just copy the data type. Okay. That's how we create the status screen. So this is the basic status screen. Next, we will proceed with the parameter map creation. So I click on the parameters tab. Now you would notice that the screen is blank. Okay, in this parameter, the sample here is the list. If you remember earlier, we created a list of refrigerants. So now we're going to use it. Okay, so let's click here. Okay. Label. Modbus refrigerant. Group. You would notice that the group this time under the parameter, the groups are no longer pre-programmed. So you might type in any group that you want. In my case, I'm just copying the one on the register list. So in this case, it's labeled a regulation. The dimensions or the address is the same process. 0, 100. The type should be changed to a word. Okay. Then for the type, select the list that we created earlier. So these are this is the list that is provided. Oh, I think I forgot something earlier. Sorry. The length has been provided 4-bit. So under dimension, you may want to change the type to 4-bit instead. Sorry about that. Okay, so you would notice here, this is how a Dixell would express their list. For example, 0 is equal to R22, 1 is equal to R134, 2 is equal to R404. That's the list that we've created earlier. You would notice that I cannot edit these values anymore. If you want to edit these, you'd have to go through the math icon. If needed. Okay, you would now notice that the new refrigerant has been added. Then this is a configurable parameter, so you may want to change the RO value. RO means read only, so you have to uncheck that for it to work. Okay, and basically that's it. Okay, any questions? Okay, we'll proceed. Okay, analog value. Okay, we will just add this one, the set point. Make sure that you don't have any spaces under the label. Under the group, regulation. I'm just copying the settings here. The dimensions. You may use hex or decimal. Let's use decimal this time. Length is word. Okay. Okay, next would be the type. you would notice that it doesn't specifically say a 16-bit sign, but you would notice that the value might have a negative range. In this case, the range is only 0 to 24 Celsius or 0 to 43. So that's those are only positive integers. So those are unsigned values. So let's put in. Okay, let's use this one. They have two gain values being displayed. So let's use the other one. This one. So, okay. Then uncheck RO. So to enable editing. Then type in the minimum and maximum values. Okay, so do you have any other questions regarding this part, or any questions about the training? Okay. If none, we will proceed now on how to upload the library to the XWEB Evo. First, we have to compile the library. In itself, even if we save this uh, library, it is still not usable. So we have to go to the device editor. Just check this. Okay. So now we will add a row here. The purpose of this is to put in a name or an identifier for the device, so that the XWEB would know what type of the device is being installed, and so that the XWEB would also be able to display the name of the device. So this case, let's call it XEB12 B. Okay, then single view. All we have to do is set it as enable. Just enable everything. Just copy and paste. For the alarm graph, this would be applicable only to the alarm register. So in this case, we only created one. That's the error PB1. So alarm graph and alarm notification, we would enable that. For the CRO, all of this should be set to read. Okay. You would notice that it didn't work with the keyboard unlock because use a right command. Okay. And that should be it for the device editor. We can now save this file. So we would notice that after saving, we would get a file with a file extension LBB. Unfortunately, that's not really useful to the XWEB at the moment. This is only useful for the Lib-builder. So in order to make this useful for the XWEB, we have to compress the file or compile the file. Sorry. Okay, so now let's proceed with this one. So we already saved the library. So now we go to export and select export Lib-builder uh, XWEB Evo zip. So this would uh, this would show you if you have any errors that maybe you've forgotten a few steps or there are errors in the file. So this is useful for troubleshooting. In this case, you would notice that it sent us an error. It says here that the family release and EEPROM is not yet set. So export is aborted. How would we remedy that? We have to go to this icon, and you will notice that the EEPROM is blank. So let's put in a random number in there because we don't have the EEPROM. Other devices might not have it. So okay. So now we can try again. Export lib XWEB evo zip. Now you would notice that the error is gone and another window would open. It will ask you where the library or the compressed file would end up in. So where it would save. Okay. So let's use this folder, for example. Just hit select. Then the tool will try to compile. Then it would show you another error if there's another error. Invalid data unit measure for refrigerant. So let's check that out. Refrigerant unit. Okay, let's erase that. Okay. Okay. If everything is good, the uh, Lib-builder tool would show you the terminate icon or the terminate message. That means that the library has been successfully exported. So the final product would look like a zip folder. Okay, so this is now the final library. So now we can now upload it to our XWEB. So how do we upload this? So we go to the XWEB Evo or XWEB Pro. Of course, we have to log in. Currently, I'm already logged in as the administrator. Now the The Lib-builder files or the libraries are considered as software patches. So you upload a software patch to enable the XWEB Pro to recognize and read your registers. So now you just click on updates, select upload, upload. Now it would look for the folder. Just select the exported library and select update. And now it shows success. Let's just try that one more time. Let's upload, select the labeled success. So now we can try to add the device or commission the device. So it would be under devices, then settings. Then for commissioning the device, you need to turn off the acquisitions. Just a bit of delay. Then now select the add device. Then source would be library. There's the library select, and then at the drop down, look for the library that we just created. The label is XEV12. So there it is. XEV12 training. So this would be the protocol. It would depend on which uh, port or which protocol is being used, but this one is the default. Then put in the address. In this case, let's just put a random number because we don't really have an actual XEV12 here. So let's say it's address 34 and have. Okay. Now, under the device dashboard, you should see it under no group because we haven't assigned it a group yet. If I start acquisitions, unfortunately, since this demo XWEB Pro is uh, a demo unit currently in Italy, so we cannot really play around with it, and we cannot attach the actual device. But this is how it would look like if it's actually online. So you would see here all of the points. These are the supervisor polling, then the command that we created earlier. Under parameters, I'm afraid we won't be able to get any of these since there's no actual device connected to the XWEB. But this is how it would normally look like. If you want it to graph other parameters, all you have to do is put a check mark on it, and it would start graphing once it gets data. Okay, do you have any questions?
Fernando, uh, just want to check with you. So just
Mm-hmm,
now the sample you are showing is you are creating a library on
mm-hmm,
XEV12D,
mm-hmm.
correct? So
Yes.
let's say if it is to do a third-party device, third-party Modbus device,
Mm-hmm,
probably it can be a BTU meter,
mm-hmm,
BTU Modbus meter.
mm-hmm.
Is it also the same method it is being applied to?
Ah, yes. You
Uh,
would use the same method, same
yeah,
because they would use the same types of registers. The only
yeah.
difference would be the format that other companies would use. So
Uh-huh.
it might look a bit different. Uh, let's see. I have a sample Modbus register here from Dixell. So it might look like this.
Uh-huh.
This is a sample. So you would notice that it is laid out very clearly because it's in a table format. So other uh, manufacturers might have a different setup for the document. So this would be a sample. You'd have to read the entire document.
Uh-huh.
But
Uh,
the
okay.
principle and the steps are the same. So the key here is make sure that you identify what type of register are you going
Uh-huh.
to map. If it's analog or digital, then if it's a coil or a holding register, because
Uh,
Dixell devices would normally use only two.
mhm.
Other manufacturers might use other types of Modbus registers.
Okay. Uh, because I think we are all, I mean, both Arctic and Lion City also are looking at maybe to add third party power meters. Uh-huh. No, they would want to create a third party power meters libraries, and then they would also want to create the library for water meter, Modbus
Mm-hmm.
water meters, maybe construct water meters, for example. Uh-huh. All these are easily created, right?
Yeah.
Uh-huh.
Basically, that's the basic way to create it. So
Uh-huh.
some might have a complicated Modbus registers.
Yeah.
So, and if that case, we would be happy to assist you.
Uh-huh.
But it would depend on the Modbus registers. It's very important that you have the document, the Modbus registers list.
Uh-huh.
Uh,
Okay. And then the other thing is I understand that after creating library for third party, I thought should they actually be sent to Dixell Italy for verification or how? Or you
mm,
can just use it just like that. Like just now you created for XEV12 for
mhm.
the that one is
Yeah.
a Dixell device. But
Yes.
if it is a third party device, do they need to send to Dixell at Italy for
Mm,
verification on the library or something like
mm.
that? Uh-huh.
Not really. You can after you created the file, you can already use it.
Uh-huh.
Uh, if you want, you can send it to Dixell so that they can keep a copy of the file just in case another customer requires it. Because
Uh-huh.
Dixell also has its own repository of files. I'm not sure if you have the link for that. They have their own list of libraries here that you can simply download. So these are all third-party devices. Actually, there are some iPro devices or Dixell devices in here as well. So it would also be good if you can send it to Dixell just for safekeeping and hosting here in the repository, just in case another site needs it. So you can simply get one from Dixell.
But basically, from what I can see, all these libraries, even though it is of same device, it can have different settings on the library itself, isn't it?
It could,
If
it could.
uh-huh,
For example, Dixell devices might have the same device but different versions.
yeah,
So, for example, the XM678 might have a 3.4, 2.8. We have a 5.4. So, yeah, even if it's the same model, it might have a different software version. So, they might have additional registers added into it.
uh-huh. But even let's not talk about Dixell own devices.
Mm-hmm.
Let's talk about maybe for example you are having a power meter uh from MH power meter.
Mm-hmm.
Uh-huh. So if the library being created by A, is it the same with the library created by B creator, an A creator versus B creator? The library most likely will be different, right?
Yeah, it depends on if they mapped all the registers and if
Uh-huh.
they share the same Modbus register list.
Uh-huh.
If they don't share the same Modbus register list, if there are differences, then yeah, there would be they would create two different files.
Uh-huh.
Also, take note that it would be up to the creator of the library to select uh, which groups would be assigned. So,
Yeah.
for example, so there might be aesthetic differences as well
Yeah. Uh-huh.
between the two guys.
Yeah. The aesthetic will be different.
Mhm. But if they share the same Modbus register document, they
Mm-hmm.
would have they should have the same addresses and the formats.
Yeah. The naming will be different.
Yeah, the naming might be a bit different if it's not
Yeah.
clear on the Modbus document.
Uh-huh.
The integrator might use his own translation or his own labeling of the
Uh-huh.
registers. So,
Uh,
yeah.
do you have any other samples of third party libraries rather than Dixell devices? Do you have
Mm,
any samples for third party libraries?
okay, we have a few projects before.
Mhm.
Do you want to see those?
Yeah, I think it will be I think Arctic and Lion City will be more interested in having third party libraries.
Uh, okay. Do you want a third party library? Let me just check.
Yeah.
Uh, uh, I'll just look into our bucket. See, that's an iPro. Just to be honest, we only receive a few requests for XWEB libraries since there's a lot of Lib-builder software out there. So,
Mm-hmm.
Most of our projects are for the E2 and Site Supervisor, but let me take a look just a moment. Okay, let me just open this project. I think this one is for a Carel device. This project, all of they don't have any configurable parameters. So all of their registers are under supervisor folder. So this is how it looks like. So this is for a Carel device. It's labeled a Carel IR33 for this one. So let me just confirm if this is the Modbus register. I think it's this one. So if you notice, it looks like it looks like just the regular registers. There's just more registers in this project. But you would notice that they would also use the same groups, same data types. Just check if I have the correct Modbus register list. Guys, ito lang pala. Jason, pakisuyo na lang. Para alam natin. Or, their Modbus register list might look a bit different. Monday hanggang Sunday. So, for example, this one, these are the Modbus registers. The parameter, if it's a read and write, so it's a bit difficult to read. Sino ba? Thermal, may connect.
Okay. So, Mr. Chan, yeah, can you hear me, Mr. Chan?
Yes, sir.
Hello, Mr. Chan, are you still there? Yeah, Chan. Do you have any question for Fernando regarding this Lib-builder? Any particular request you might want Fernando to show? Hello, yeah, Mr. Chan, are you there? Yeah, Mr. Chan, cannot hear from you.
Hear me now?
Yeah, hello.
Yeah, everything is quite clear. So yeah,
Uh-huh.
it's almost coincide with all the Modbus register address I have get hold from my supplier.
Uh-huh. So basically, any particular devices which you might have in mind to add in libraries for the XWEB Pro?
Tentatively, no. I need to add in some third-party device like the water meter, power meter, yeah, and some funny controller that my user gave me. Yeah, I think that's all. So everything quite clear. This one quite standard one. Yeah, so should be easy.
Uh-huh. Yeah. Good to hear that. Uh-huh. Yeah. Leon, at your side, any particular concern?
I see those like a bit more to programming lah, I see, for this library builder.
Uh-huh. But this will be on the integration, especially on the third-party devices like the power meters and the water meters, maybe. So, will your site be, will it be useful for your site as well?
Still not sure yet for time being. But I
Yeah,
just want to ask, in case in future, in case we need it, let's
yeah.
say I program it, is it possible I send for you or and Manila like that to verify for me? Hello?
Yeah. Fernando, do you mind answer for Leon? Uh-huh. Any support? Who should we get support from for this library builder? Yeah, Fernando. Yeah, Fernando. Who should we get support from?
Okay, sorry.
Yeah.
Uh, for integration inquiries, library inquiries, you might reach for us. For example, me, Fernando.
Uh-huh.
I'm and Wilson. We have a team of integrators here that might help you. That would be available to help you.
Mm-hmm. Okay. Noted.
Noted.
Okay. But if there's for example, if you encounter problems with the tool itself, we might have to escalate it to Dixell Italy. But if it's just if it's an integration request, then yeah, I think we can support you with that one. Okay, any more questions?
Fernando?
Yes.
Fernando? So
Yep.
basically, we need to program the digital input, the command, and the signal for the XWEB to read it, right?
Sorry, can you repeat that one more time? Thank you.
Because basically, I see the way how we programmed just now.
Mm-hmm.
You're programming the command, digital input, is it correct?
Uh-huh.
And then is the, I think it's some sort of connection between XWEB and the library. Is it real?
The XWEB and the library. Yes, the library is more of a patch that you put into the XWEB to enable it to read or send the commands to the device. As long as the
So-
device is connected through Modbus, that should work.
So mean different third-party device will be different setup, right?
You mean on wiring?
I mean the programming.
Programming. Yes. They might have a different programming setup, but as long as the registers are correct, it should work. It should work as long as the registers are correct.
Okay. So I think in future, if we need it, maybe we will need a bit of your support lah.
Dapat natin lagyan, balik mo doon. Kasi pagkasalan mo dyan at pinost mo, mag-i-email yung database ng customer, di ba? Close mo. Pag-complain yun, kasi ang completion dapat natin ipasawaran kay department. Kasi hindi pa tayo. Any other questions?
No, I'm good.
Okay. If there are no more questions, I'd like to thank you for attending today's session. I will send the slide shortly, the training slides that I've used for today's session. I'm going to send it to Stanley, to Mr. Wong, and he's going to send the files to you guys.
Okay, thank you very much.
Okay, thank you.
Thanks a lot, Fernando.
You're welcome. Have a
Okay.
good day, gentlemen.
Have a good day.
Okay.
Yeah, have a good
Have
day.
a good day.
Yeah, thank you.